Assalamu alaikum. Myself Mariam Ali, and today I'm going to explain some basic operations of logic gates. Here I place 7 types of logic gates. These logic gates contain their specific operations, and most commonly logic gates have two binary inputs which generate a single output as 1 and 0. Here in Proteus, I place an LED. When it is on, it represents 1 at high state, and when it is off, it represents 0 at low state. These ICs have their operations, but before getting into it, let's get a crude view of these ICs, which is shown here. Digital logic systems contain two types of TTL logic ICs and CMOS logic ICs. These are the standard commercially two kinds of logic ICs. TTL stands for transistor-transistor logic and CMOS stands for complementary metal oxide semiconductors. These metal oxide semiconductor ICs are most commonly used because they have excellent output voltage, and similarly they have the same material as used in the TTL, but they have high density as compared to TTL. Here in the Proteus, I took 74 series ICs and I'm working on it. So let's get into their basic operations. Firstly, NOT gate. NOT gate contains only one input and only one output. It is also known as hex inverter cause it's IC known as hex inverter cause it whatever the input is, it converts it into the output in its reverse form. Like here in the truth table, whatever the output is, the whatever the input is, the output is the complement of it. Like 0, output is 1, and like 1, output is 0. Let's get it more by its simulation. Here as the switch is on at 1, but the LED is off at 0. But when it is off, the LED is on. So that is why it is known as hex inverter or inverter simply. The next gate is AND gate. In AND gate, it is only at the output is at high state when the both input are at high state. Otherwise, it is off. Here, as shown, a simulation when both the switches are at on condition, at the LED is on. Let get the first switch off. So here as shown, the LED is off. Similarly, when the both are on. The next gate is OR gate. OR gate represented by the plus sign, and its IC is 7432. In this, when the only one input is high state, the output is at high state, but when both are at low state, the output is also at low state. Let's get into this gate simulation or gate. Here is shown the both switches are on, so the LED is on. Let's make one switch off, but still the LED is on as it is defined by its truth table. But when both are off, the LED is off. Let's get into the further gate, NAND gate. NAND gate is actually the combination of two gates, that is NOT gate and AND gate. As we studied before, the AND gate and NOT gate, it is a combination of it, as whatever the output of AND gate gives, the NOT gate get the reverse of it. So in the OR NOT, in the AND gate, as it is shown, when both are at high state, the output is as high state. But in the NAND gate, as shown, only when the both are at high state, the output is at low state. That is why it is a combination of NOT and AND. Let's get into the simulation. Its IC is 7400. Let's get into simulation. Here as shown, the both are at high state, but still the LED is not on, because it contains a NOT gate which get the reverse of AND gate input. But when one switch is off, LED gets on. Similarly, when both are on, the LED is on, as shown by its truth table. Let's get into the next gate, XOR. These gates are exclusive OR gate. It consists of two inputs, but its IC, which is 7486, it contains 4 XOR gates inside it. So the basic operation of XOR gate is when only one input is high, it is at high state. Otherwise, if both inputs are at 0 or at high state or at low state, or further we can say that when the both inputs are at equal state, the output is at low state, or in short, the IC is off. IC nahi, LED is off. So as shown here, the both are at similar state. If one is at different state, like one is as on, the other is off, so the LED is on. But when the both are at off state, the LED is off, as shown by its truth table. And it represented is by plus sign, encircle plus sign, as OR gate is contain plus, but XOR gate contain a encircle plus sign. Let's get into the next gate, NOR gate. This NOR gate is a combination of NOT and OR, like the NAND gate is a combination of NOT and OR. It is a combination of NOT and OR. In this, the OR output is reversed by the NOT gate. As in OR gate, when only a single input is at high state, the output is at high state. But as it contains a NOT gate, it gets the reverse of it. Like at input, at least one input is at high state, but the output is at low state because the NOT gate gets the reverse of it. Let's get into a simulation. NOT gate. Here is shown when the both are at 0 state, the LED is on, as is shown by its truth table. But otherwise, it gets off. At all other conditions, the LED is off. Let's get into our last gate, that is XNOR gate, exclusive NOR gate. So the exclusive NOR gate is also represented as encircle plus sign, but it gets a complement over it, that is NOT gate. So In this truth table as shown, when both states are same, the output is on, or we can say that the output is at high state. Otherwise, the output is at low state or at 0. So let's get into it. Simulation. As shown here, the both switch are at similar state, but if we get the one switch at 1 at off and the other is at on, the output is off, means the LED is at 0 state. So here is the simple basic operations of logic gates. Hope so you understand it, and thank you for understanding it. Thank you.